Bye.
Hi everyone, it's Deepak. Is my sound is okay? Yeah? Okay. No?
It's on, but
Hi. And now?
grab it lower than it's higher to your mouth.
Okay. Now. Okay. Okay, it's the first time I'm using hand mic, so it sucks. Okay. So I changed my title a bit. It's not intelligent anymore. Now it's super awesome. And after attending Raymond talk and Python got so many awesome features, then I thought that let's call this talk super awesome, you know. So I'm Deepak, and I studied CS, just like some of you guys. How many of you have studied artificial intelligence at universities? So quite a lot. So this talk is more about artificial intelligence than using some kind of framework or you're using some kind of design patterns. So basically, I love data, and I love to hack it, and I also love Python. But before I started hacking data, I was writing so many code at university, you know, how to fix data and how to represent in a way so that other machine can read it. So why Python? Because it's awesome. So we have no excuse to not use Python. And it has got awesome web framework as well. And so some of them are here. For example, Django is quite awesome. Cherry Pie is also awesome. And TurboGear is also cool. I wouldn't say it's awesome, but it's cool. Yeah, in a way. So and then we have more Pylon and Zope. I mean, some people still use it. I mean, for those for those, I think most of them who use Plone, I guess. So and there are so many frameworks that even some people say that they have their own framework and it's their favorite super awesome framework. So what's the formula of making us an awesome app? And awesome is different than super awesome because because awesome is something when you use awesome tools, you have awesome idea, and you have awesome user interface, and then you build an awesome app. So the main idea is that you have an awesome idea, which is the core, which no one can help you with that. And then you have awesome tools and awesome web framework which you can use, for example, Django or some other. And then you have to build an awesome user interface. I mean, based on my experience, I'm a data engineer, and I don't care about user interface much. But believe me, it matters. It really matters. And a good UI designer can give you 100 argument that user interface should be much better. But you wouldn't trust as a data engineer. But when the code goes live or the web app goes live, then you see so many people. They use your app, and then you feel that, oh, you were wrong, and he was right. So it's the idea, how to make an awesome app. So back in 15 years, when I was a student in secondary school, it was really hard to think like this. And I saw a Hotmail, and it was quite cool, and I wanted to make something like an HTML page, but I didn't know it's called HTML. So I found an awesome website, which was this, which helped me a lot. As you can see, that user interface, I mean, if you compare now, then it sucks, but at that time it was quite cool and very informative. And the link here create your personal homepage. It's misleading. I clicked there almost 100 times, and and I never got any useful information there. So the first thing which I searched there is how to make Hotmail. So it was quite weird because I didn't get any results, and I mean I got results for Hotmail, and then I could check my email. It's weird. So then I searched more, and then I got to know a word which is called HTML. So the keyword I was looking for was HTML, but it took me around 3 days, around 8 hours, and it was very expensive to use internet at that time. So, but 2 years later, in 1998, something super awesome came, and it was this. and the thing why it was super awesome, and the reason was that I could write anything, and I was always getting the result which I was looking for. Because at that time, information was very less, and it was very easy to find useful information.
That thing was written in Python, too.
That's cool. So that is why it's super awesome. And so the thing is, why we need intelligence in our application. It's, at this point, it's very important because information looks like this. It's overloaded. It's everywhere. There's so much information, then it's extremely hard. I would say it's wickedly hard to find useful information from the bulk. So if you see the stats, that it's also very. I mean, for me, it's nice because I love data. There's a lot of data. There are around 130 million websites at the time. I guess there are more, and there are around 150 million tweets every day. And out of them, there are 2 million tweets are just pictures. And there are around 4 million blog posts every day at WordPress. So if you studied computer science, and if you know a bit about artificial intelligence, then this thing gives you a picture of future, that how our future is going to look like. And it's not very nice if you have so much information, and then you need a lot of research to fix these things for you. So the more reason that why you need intelligence is that you want to do something new in your application. I have seen so many guys, they are talking to me. For example, one guy, he wanted to make an iPhone app, and he wanted to take a picture, but he on this picture he wanted that this image should be segmented so that you can see different areas, and you can pinpoint and change the color. And the idea was very awesome, but he didn't know that it's very easy to solve if you know artificial intelligence, or if you know clustering in general. So there are some cases like this as well. And if you want to stay in competition, you have a cool idea, you have an awesome website, you have awesome super awesome users, and you have a scalable architecture, but you need to ask that, are you prepared for future? There is so much information that you can extract, or you need to solve something. So you need to ask that the information that you have is really useful, will be really useful in future. And the last reason, that there are so many things to do. Since I'm a scientist, so I like the last one, that there are so many things to do with data. So what exactly is a machine learning? Actually, it's very simple, algorithm that can allow your machine to learn. And there are a few examples in real world which you use every day, I guess. The spam detection. Actually, spam detection was the first thing, I mean, which I ever did at university. It's very easy that you have some emails, you can detect that whether they are spam or not. And the second example, what you might use, I think most of them uses the Google News. It's very neat example how to cluster your data and then how to personalize ranking. I mean, which news should be on top, which news should be at bottom. And then there are a few examples like Facebook, where when you log into Facebook, then you see that you may know these people as well. So it's also something to do with not machine learning in general, but yeah, artificial intelligence. So I think there is a talk by Rob, and it's about how to decide prices of your products, and it's also a part of machine artificial intelligence. And there are so many other things which you can do. So basically, when we talk about machine learning, there are two things which, there are two types of algorithm. There's supervised and unsupervised. So what you do in supervised, that you take your data and then you use some part of data to train it, and then you use some other part of data or some new observation to say that, okay, this data is good or not. I mean, not good or not, but it belongs to this class or not, actually. So in supervised, there are a few kind of algorithm, and there are more. Classification is one of the most common which people uses, and then you have artificial neural network, and then you have some regression, etc. And unsupervised is something that you have your data, but you don't know that in which part you should divide the data. You don't have answers actually. So you don't train it. You just iterate or apply some algorithm to it. And the good example is clustering and self-organized map. I'm not going to talk about self-organized map because it's quite hard to talk in Python. In Python, there are over 20 Python modules which you can use it. You don't have to write your own algorithms. And some of them, which I would recommend is scikit.learn, because it's made for unstructured data, so it's quite cool. And MDP is also cool because it's pure Python. And if you heard of support vector machine, then I would recommend libsvn. But the thing is that none of them have everything. So you might have to use different modules for different things in your. As I said, that MDP is pure Python. So if you guys just want to have pure Python code, then MDP might appeal to you. But the scikit.learn is also quite awesome because it has a very cool way to extract features. And actually, what's the main problem? Why you can't use these all things? Why these all things are not fully? And the main reason is that they can't read your feature. So you have to extract your feature, and then you have to put it into some kind of algorithms. Machine learning algorithm. So if you know how to extract feature, then you are almost halfway there. So the first thing which I'm going to talk about, clustering in general. So the main idea here is that you have n items, you want to form a k groups, and actually it's not very hard. And if you know what you need, then it's not really hard. And there are so many type of algorithm which you can apply: hierarchical, k-mean, quality threshold, fuzzy c-mean, or LSH, is locality sensitive hashing, which was developed at Stanford. So it's quite cool. So, but I will take the easiest one, and it's k-means. So the idea is very simple. You have n items. This n items can be, for example, news articles, and your app is aggregating news articles, and you want to divide into, like, these all news belongs to the same group. These all news are similar to each other. So if you want to do something like this, then you should probably use clustering. And the main idea is that you have your n news article here, and you choose you choose k centroid, and I mean it's at random. You just apply a randomizer, and then you pick k centroid from your n news article, and then you compute distance between the center and the news article. And I mean the centroid itself is a news article, so you just find the distance between them, and you append it to a centroid which is more near to the news article. And as you can see here, that here, this is something which you don't really want, because you can see it that it's wrong. So you have to adjust your centroid. And how to do is that you recompute the centroid based on your cluster, and you adjust it, and you repeat this until your iteration converge. So so now you know something about this, so how to group. Yeah.
Can you describe the process for adjusting your choice of centroids?
Yeah, you have to use some kind of distance function for that. You have to find distance between your story. Let's take an example, like a news story. Yeah. So you have two news story, and you want to know that how they are related. So you find a distance between your stories. If they are more near, so you put it into the same cluster. So when you have your centroid, when you have your first iteration, then you get a group, and then you readjust the centroid, because you have a group and you have a centroid somewhere, and then you see that it's not exactly my centroid, so you readjust somewhere else. So the main idea is that you have to compute distance. So let's take an example, and in this example, we will make a Django app, and which aggregates news articles from different sources. So I guess you all know Django, so I don't have to talk. What is it? So the main idea here is that you specify your news source, and then you specify your news items. Then you make a label called cluster, and then you just put a signal on your post save that whenever you add a news source, and so that you pass the RSS feed, and you feed it into news articles. And after that, you build an awesome UI, which is very important, believe me. And now we can enhance it and make it more awesome by using some kind of grouping algorithms, which I've been talking in this case, k-means. So the first thing is that you have to find distance between your news story. And if you need to find distance, actually it's not very hard. So let's take an example. You have two stories which I took like 2 days back, and if you can see that these stories, they looks very similar. For human it's very obvious, but for machine, how we can do this in machine? So if you see these two stories, you say that yes, it looks very similar. So the distance is complementary to similarity. So if two items are similar, then distance is more smaller. So what we can say is that the distance between A and B is 1 minus similarity between A and B. And in sets, it's very easy to find. You just find intersection, and then you divide it by union, and it's also called Yuckard similarity, base one. And if your data is huge and you don't want to apply such expensive operation, then you can also use min hash. And it's also quite advanced, but yeah.
What does n do? N
Is a number of element in sets, in set theory. It's in Python you can say len, and then you can say set one intersections a dot intersection b, and then you can divide by len a union b. So if you see the story and you compute, then you can say that the distance between these two stories is 0.75. Actually, it's quite a big, but that's something which is very very hard to find in your data. That what should be the range of your threshold. So in Python, it's actually not very hard to implement. As you can see, that you first need to extract feature. You take a string with the news items, title and content. You strip all stop words, and then you split them up to form some kind of set, which is also called bag of words. And then you find similarity, which is just a set in intersection and set union here. And then you just subtract by 1 and you get a distance. Now after that, you need to think. Now you have your feature, you have your distance function, but what you really need is that what kind of algorithm you need to apply on it. So the easiest way is you apply k-mean algorithm, but the k-mean algorithm itself is not suitable in this case, because you know your size of cluster, and that's not desired in this case, because you can have very sparse data, and then you may not need to cluster items into a limited group. So you need a flexibility. So let's change a bit. So what we can do is that we can say that if we have two story, and if the distance between them is smaller than delta, which is our threshold, then we will append it to cluster. So what it allows us that we are no longer dependent on k. So if you have empty groups, then you can just drop them, and you can apply you can rerun that thing, and then you will get you will get some groups, and then you will again drop empty groups, and then you will rerun it, and so on until you are satisfied. So it looks very similar to canopy clustering, which is very new, and yeah, I'm not going to talk much about it. So in Python, it's also not very hard to implement. You just have a class cluster, and then you pass your items, and you pass your distance function, and then you apply your k-mean algorithm. And this algorithm is quite simple. So first you take your items, and then you at random you select k centers, and then you remove these k centers from the items which you want to cluster. So and after that you just assume that the series will converge in 50 iterations or 100 iterations or 300 iterations. But I think for this algorithm 50 is enough. I found that here it converges into 8 to 10 iterations. So you form empty groups here, and you form k empty groups here, and then you then you iterate through your items, and then you find the distance between centroid and items, and if this items and if the distance is minimum and it's below the threshold, then you append it to your group, and you do it again. You do it again and again until the last and the best is the same, and after that you readjust your center, since you know that what is your cluster, and then you can move your centroid, and then you rerun it until you get the same results. So if we run it here, and then I use sample data, and then I ran, and the results were not so bad actually. So I have around 500 news articles. I was able to cluster around 120 of them, and I had 8 news sources. So as you can see that you can see almost the algorithm works. What? Okay. I'm sorry. So it looks like that I've been over speaking. Okay, so if you run the algorithm, then you see something like this. So I will go extremely fast now. So there are more examples. You can recognize handwriting. It's also fairly simple, and then you can subdivide images into some kind of areas, and then if you use Google Maps and there are so many places, then you can cluster this label on map, and then also you can do some kind of sale BI thing. So the second technique is classification. So for kid is very obvious to do this thing. I mean for us also. So you have some items, and you want to tell that it belongs to this class, or it belongs to that class, or it belongs to something else. So kid see it, and then he see the picture, and then he can recognize that it's this. So the idea is the same here. So so the thing is that we present an observation, and then we train the system, and then we give something unseen which is not in the system, and then we expect the system will tell that it belongs to X class, or it belongs to Y. Like in case of spam, it tells you the new email is a spam or ham. So here's a simple bias classifier, and it's a math here that there are two groups, red and green, and there are 40 green and 20 red, and you need to and then you give a white dot, and then you ask the system that is this white dot is green or red. So if you do it, then if you use a bias classifier, then you can easily do this. So I will skip it to some example sample app. Let's make an app, and in this app, what we do is that we take our tweets, and then we tell that these tweets are happy tweets or sad tweets. And actually, it's not very hard also. So you just make a Django model, which is very simple. You take an author, you put a tweet, and then you put a sentiment, and the sentiment can be happy or sad or neutral. And then you use a Bayesian classifier, and then you train your data that what is happy. So if there are words like happy, awesome, amazing, impressed, or smiley, then it's happy, of course. And if something like sad, sucks, problem, headache, or sad smiley, then it's sad. So and then we train the system, and then we ask, EuroPython is awesome this year, and it says yes, it's happy tweet. So the guy who wrote this tweet is happy. And let's take in some example which I used from EuroPython feed, and someone I don't know who wrote this. Then he wrote that he wrote something, packing done, tomorrow flying to Frankfurt, Hahn to Pisa, ready for a great week to the EuroPython, and it's happy. And someone wrote back to small for running shoes, and of course it's a sad. So but you can also improve the system if you train it by your results, or use human computing. And suppose you say that it's spam or not, or it's happy or sad, that you add a link that is it really happy, and if someone say no, it's not happy, then you train by that example. And the last thing which I'm going to talk about is recommendation system. It works. It works the same way. Like if I buy something, and I tell to my friend that, hey, this thing is awesome, and then he say, is it? And then he also buy. So the idea is to emulate the same behavior in machine, so that that our social environment is more our social shopping become more social. So you can either recommend things by user based or by items, like Amazon they use item based, and some other use user based, like Twitter, like they use they see your friends and then friends of friend, and then they recommend you more friends. So user based recommendation. It's more about to finding similar users first, and then you find the intersection between their interest, and it's very easy to implement, but it's very slow because the amount of users are huge, and the users changes very often, that they like this now and they don't like this more. But for social sites, it makes more sense. And in the item-based system, that you recommend items, and since item they don't change very often, and it's very easy to run, and it's extremely faster. And it makes more sense when you sell something, and you want to find that if X user bought this, then Y user should also buy this. So as I told you, that you user change very fast, so you user-based recommendation systems are very slow, but item-based are quite fast. And the few examples, like you have seen this recommendation system at last.fm and Facebook, Twitter, and even ads, and that's it. So if you're scared of this algorithm, then I would recommend you to use some of the tools which already exist. In my opinion, scikit-learn is an awesome tool. Unfortunately, it's not in pure Python. And then you can also use prediction API, and you can train your data, and then you can tell that it's spam or it's not, or it's happy or it's sad. It's quite easy with prediction API. And the one interesting thing is Apache Mahout, and it's also a cool tool, but it's written in Java, and for those who love to code in Python, they can use JPyP. And some of the cases are that when none of these things fit, and you want to use human, and then you can use a service from Amazon, which you can upload your assignment, and real people are doing for you. So this machine learning thing are not 100% accurate for sure. So if you really care about accuracy, then you should think using human computing. And as the data grow, then it become extremely hard for people to run algorithm, because it's so expensive. And in some cases, you just don't know what to do. and there are more reasons that is why we shouldn't use machine learning. But one of the thing is Darwin said that it's not the most intelligent and most strong who is going to survive. It's most adaptable who is going to survive. So you have to adopt your algorithms. So you make your awesome app. You use your awesome idea. Use awesome architecture. Then you use awesome framework. Then you use awesome UI. Then you use some awesome cloud solution. And then you have your awesome app. But if you want to make it super awesome, then I would highly recommend you that do something interesting with your data, and it's worth it. I would highly recommend this book from Toby Sagarin, and it's quite nice, and it's used Python examples, and it's the core, I would say. And there are other useful things which you can do in machine learning if you're interested in it. That you can use support vector machine for classifying, and it's amazingly it gives you amazing improvement over some other algorithm. You can also use some kind of other algorithm which I mentioned here to improve your system. And you guys are awesome. You make your awesome app, and these all examples are available on GitHub, so you can just go and see or something like this. I think that's it. I don't have much time left. So if you have any questions, please. I guess you should.
Can we have another look at the source code? Sorry.
Yeah, I mean, you can.
Blimey.
You can.
Can we have another look at the source code for the k-means algorithm?
Yeah, you can dump the whole source code from here.
Yeah, but can we look at it now?
Yeah.
The next one. Cool. I mean, if no one else has any questions, would you go through it and explain it in more detail?
I mean, okay. As I told you, I mean, as I've already explained, but I will still do again. The first thing is that what you do is that you select your k items from an item, and then you call them that it's your centroid.
Uh-huh.
Yeah, and then you form this empty K clusters here.
Yeah.
And then you take your all items which you want to group, and then you pass it through centroid one by one. And then you compare distance between the item and the centroid one by one.
Okay.
And it's here. And if it's if it's smaller than your threshold, and if it's smaller than your threshold, then you just attach it to cluster.
Okay, the threshold is constant.
It's not exactly k-means, because in k-means there is no concept of threshold. So it's the key, because your data is, your data is news article, and you don't want to say that I have 100 news and I want to form 5 cluster out of it. It makes no sense. So you need to make. I want something which looks similar, and the similarity between them should be around 20%.
Okay.
So if you do that way, then you avoid grouping the useless articles. So yeah.
Still on the code, is there an upper bound for the Is there an upper bound on the convergence? How do you compute it?
Well, yes, there is, there it's if you know k-means algorithm, then its lower bound is big O and D, and D is dimension of your data. And it's quite hard when you have very highly dimensional data.
So why not using the upper bound instead of an arbitrary number in the algorithm, the 50 thing?
You can certainly use that as well. It's up to you. I prefer that. I already did this app, and I did in this way. You can change this algorithm in the way you want. So it's not really a case if you know what you are doing.
Mm-hmm. Okay, thanks.
There's one there.
Yes.
Hello there. So last year at EuroPython, I did a lightning talk on a face tracking robot, and then ran a birds of a feather session on AI. I'm guessing, since a bunch of hands went up for AI earlier, that maybe they'll be interested in running a birds of a feather session again this year. If I were to stick an event name up on the free space outside in the next day or two, would anyone be interested in getting together and talking about whatever AI problems you're solving? Sorry? No, I haven't got the robot. Is that Harold? No. Oh, Harold, yeah. No robot this year, sorry. Hands up, anyone would be interested in an AI birds of a feather session?
Sure.
Yeah? 1, 2, 3?
For sure.
Okay, I'll stick up a talk in the next couple of days. Cool. Oh, wait, just a session.
Okay. There's one there. Okay, Max.
At the beginning, you showed us some packages or models in Python to do these kind of things. Mm-hmm. I have a problem in one of my applications. I have used something like business logic, let's say so, which is kindly different from this one, but this seems to be a different approach. Moving the computation from the database to the application, it's good for me. It's another machine that can do the calculation, okay. Do you know if any of those libraries you showed us in the list, or if there is something else which can give these machine intelligence to a higher level libraries which can be used for business intelligence? Because usually when you search for open source and business intelligence, in my experience, I was frustrated because everyone told me if you want something big, use Pentaho, but Pentaho is for Java. I don't want to use Java. So this seems to be like a lower layer for building something up, like for IRP or.
But I would highly recommend you, if you haven't used it, then I would highly recommend you to use scikit.learn. Actually, it covers almost 80% of the things which you would need for BI. So it's nice. It's nice. It's more nicer than other like MDP, which is very strict to some things, and other like PY Brain, or I don't know which one you have used. So.
Can you go back to the last slide? Sorry.
Which one?
The last one.
Okay.
Your GitHub repository.
Okay. There is a QR code. If you use smartphone, you can just scan it. Okay. Yeah, sure.
Hi, I was wondering, you showed us how to do k-means clustering, and then the news site.
What?
And then you showed the news site.
Yeah.
But you're only calculating distances between the stories, I guess.
Yeah.
So how do you do the clustering then?
Actually, it's the same algorithm which I have shown it. So what we do is that we take a news article, and then we say that until this range, whatever it comes, that they should fall in the same cluster. So you find that.
So you're not calculating centroids anymore, but you're.
No, we are doing that. So what we are doing is that we find a distance between centroid and the news article, and we form a group. And then what you really need to do is that you need to see that the centroid that you have chosen is actually a centroid for that circle. If not, then you find average values, and then you move it somewhere else. And then you rerun, and then if you see that your group is the same as it was before, so you say that okay, stop it. So it's the end.
Okay. Yep.
Some more questions? I don't know.
Still 10 minutes.
Oh. Okay. Okay, I guess.
Okay.
So.
Thank you.
Thank you.